Imagine drifting toward a place where space itself becomes a waterfall. A black hole is not a tunnel in space, but a region where gravity bends reality beyond escape. From far away, it looks calm, a dark sphere surrounded by glowing gas. Yet every second matter falls inward at nearly light speed. The moment you cross its boundary, called the event horizon, the universe outside can still be seen, but you can never return. Long before reaching the horizon, you would notice strange distortions. Stars behind the black hole stretch into bright arcs called gravitational lensing. The sky wraps around the darkness like a mere sphere. Light no longer travels straight. It curves along space-time itself. You could see the back of your own ship ahead of you. Space stops behaving like distance and begins behaving like geometry. Time also changes. To distant observers, you appear to slow down, your movements stretching longer and longer. From their perspective, you freeze near the horizon forever, fading redder and dimmer. But inside your ship, everything feels normal. Your clock ticks steadily. This difference is called time dilation. Gravity literally separates timelines between you and the outside universe. Crossing the event horizon feels surprisingly gentle. There is no sudden impact, no wall, no flash. The boundary is invisible. The real danger comes from tidal forces, differences in gravity between your head and feet. In small black holes, you would be stretched instantly into a thin stream of atoms, a process scientists call spaghettification. 5 in a supermassive black hole, like the one in our galaxy center, the crossing could be survivable for minutes. You would fall freely, weightless, toward the core. Outside, stars compress into a bright ring above you. The universe appears to speed up, galaxies evolving rapidly because your time runs slower relative to theirs. Radiation becomes deadly. The accretion disk surrounding many black holes shines hotter than stars. X-rays and gamma rays blast nearby space. If you approached actively feeding black hole matter, your ship would heat like a meteor entering atmosphere, but with no air, only energy intense enough to strip atoms apart. Deeper inside, directions lose meaning. All possible paths lead inward. Moving forward in space becomes equivalent to moving forward in time. You cannot turn around because the future itself points toward the singularity. Escape would require traveling backward in time, which physics forbids. Looking outward, you might see the entire future of the universe unfold quickly. Stars age, galaxies collide, cosmic expansion accelerates. In theory, during your final fall, you could witness billions of years pass outside within moments of your own experience. Near the center, gravity gradients grow extreme. Even supermassive black holes eventually tear apart molecules, then atoms, then atomic nuclei. Matter compresses beyond known states into exotic quantum structures. Physics here becomes uncertain. Our equations break. The singularity itself is not a point you can see. It is where space-time curvature becomes infinite in classical theory. Distances shrink to zero while density becomes endless. Some physicists think quantum gravity replaces it with a finite region, but no experiment can yet confirm. Information presents a mystery. If everything falls in, does it disappear? Modern theory suggests it is encoded on the event horizon surface, the holographic principle. The black hole behaves like a cosmic memory, storing the history of everything it consumes. Over immense time scales, black holes slowly evaporate through Hawking radiation. Tiny particles leak away, carrying bits of information. A black hole larger than the sun lasts longer than the current age of the universe many times over, but eventually even giants fade. If you fell in, your atoms would not be lost forever. After unimaginable ages, they could re-emerge as faint radiation spread across space. You would not survive, but your physical information might persist as subtle quantum patterns. Some speculative theories suggest the interior connects to other regions of spacetime, perhaps even new universes. These wormhole ideas remain unproven, yet they show how black holes sit at the border between gravity and quantum reality. To the outside cosmos, your journey ends at the horizon. To you, it continues inward until physics itself becomes unknown. Black holes are not just objects. They are laboratories testing the limits of nature's laws. Inside a black hole, distance becomes time, future becomes direction, and certainty becomes mystery. The final journey is not just toward destruction, but toward the deepest question in science: what truly happens when space and time reach their ultimate limit?